right, Peter.
I'm back.
We're ready to rock.
All right. So I'm good to go then, huh?
Yep, all good to go.
All right. Well, hi, everybody. The previous 3 weeks, we've been focusing on the microbial aspect and, the work of yeast and bacteria, which are at the heart of fermentation, whether for beer, bread, cheese, whatever. But today, I'd like to broaden the scope and focus on the process that transforms this microbial and biological process into a finished product, in this instance, bread. So we're going to call today's presentation The Fundamentals of Bread Baking Science, or The Journey from Wheat to Eat. Now, we call it bread baking science, so let's talk about baking first. We got to lay down a couple of kind of key terms here. So baking, as in all cooking, is an act of transformation. All cooking is transformational. And by transformation, I mean a radical change in an object from one thing into something totally new and different. Since I'm going to be using this word a lot today, I just want to make sure that we all understand what I mean by that, a radical change from from one thing into something else. And the key here is this notion of transformation. How do we explain why this radical change happens? That's what this presentation is about. So we'll start with the definition. And again, this is real fundamental, and this is textbook. The definition of baking is the application of heat to a product in an enclosed environment, meaning an oven, for the purpose of driving off moisture. There's nothing in that definition that talks about transformations or anything else, but it's this process of baking that allows for transformation to take place at the baking level as we go through our journey of bread baking. When we get to the baking stage, this is where a lot of transformations and the final transformations actually occur. And it occurs, and by the way, baking is very different from, say, roasting, which is also done in an oven. But in the definition of roasting, you use moist heat. So the purpose is not necessarily to drive off moisture, but driving off moisture is very critical in the bread baking process, because if you put a loaf of bread in that weighs, the dough weighs, let's say, 18 ounces, it's more likely to come out of the oven weighing about 15 or 16 ounces because of evaporation of moisture. We're driving off moisture. So all the transformations that happen during the baking process occur within this triangle. And this triangle depicts the relationship between time, temperature, and ingredients. Anything that happens at one of these points on the triangle affects the other 2 points. An example would be if you raise the temperature of the oven when you're baking, it's going to make the loaf faster, obviously, but it also may affect the ingredients on how they bake, how they caramelize, and whether the outside gets done too quickly. And our goal in baking, especially baking bread, is we want the outside and the inside of the loaf to get baked and finished at the same time. And there's an awful lot of drama that's going to be going on to make that happen. But the craft of baking really comes down to managing time, temperature, and ingredients, and understanding through practice and following instructions and figuring it out and eventually getting a feel for it, how to balance those three to give you the best product possible. The difference between an average baker and a craft or artisan baker and the quality of the breads that they produce is really, they're all working with the same ingredients, but some have a much better sense of how to control these factors. So I call this the baking triangle, and everything that we talked about is going to happen within the context of that. So on the transformational journey of the loaf of bread, there are 12 distinct stages that take us from wheat to eat. Now I'm using 12. I've seen in other books 10, 8. Everyone has a different way of describing it. This is not, the only way of giving context to what goes on in this journey. But this is the way I define it, and I think it helps us to get our mind around it and give us a sense of structure as we think about all the things that are going on in the loaf. And there are a couple of key stages. So stage one, as in all cooking, we use the term mise en place, which means, the French coined that one, means everything in its place. I call it the organizational principle, get organized. but in baking, we call it scaling, meaning weighing or scaling out or even measuring your ingredients. But in this case, with bread, I want to go back and say that mise en place really goes way back to the field itself. So our mise en place really begins with wheat or grain, but we're going to focus on wheat today because that is the primary grain for bread, mainly because it has the most gluten of any grain, and it also tastes great. So wheat growing in the field is essentially a grass that puts out seeds. It's alive. It's a living thing. So the first transformation in this journey is going to be alive to dead, because when we harvest that wheat, when we gather the seeds of that wheat and we take it to the mill where it is crushed into flour, we kill the life-giving properties of that seed. It is destroyed. So we've just taken a living thing and made it dead. I always say that harvesting is just a euphemism for killing, but that's what we've done. And then what we take it, we do with that flour is we combine it with other ingredients that we've scaled out to begin the dough making process. So then we move into stage two. We've got our ingredients, we've gathered them, and there are three distinct objectives that have to happen during the mixing process. One is we want to evenly distribute the ingredients. We don't want little clumps of salt or yeast or any other things that we're putting in there. We need to get them properly spread, and that happens automatically just by mixing, and that can be done by hand or by machine. There's no rule about this, but it's mostly done by machine in production because the human body just can't handle a big piece of dough. But if you're making it at home, there's no reason why a machine should be any better than doing it by hand, and hand mixing actually is in many ways more satisfying. Another objective is the activation of the yeast. Now, yeast can come in a lot of forms. It could be powdered, dry yeast. It could be a sort of a soft, cakey yeast. It could be a liquid yeast. It could be sourdough yeast, which is what we're going to be mainly using as we progress through this fermentology series of webinars. But we have to activate it, because until we put it into the dough, it's basically lying dormant, waiting to be activated. A sourdough starter is already active, but it's kind of sitting there waiting to be deployed. So once we hydrate the dough, because one of the ingredients is going to be water or some liquid, the yeast wakes up and begins seeking out food. And then the third thing that has to happen is we have to develop the gluten. And that's, again, goes back to the wheat. Wheat has more gluten than any other grain. Rye comes in second, barley a distant third, and there may be traces of gluten in some other grains, but mostly other grains are essentially gluten-free unless they've been cross-pollinated or cross-contaminated. But the problem is with gluten is that there is no such thing as gluten in wheat. A lot of people think that gluten is, exists in wheat, but really wheat just has the potential to make gluten. What it does have are two partial proteins or small proteins called gliadin and glutenin. And these two proteins, neither of which are strong enough to make a dough both extensible and elastic, when they get hydrated, they seek out each other and they bond. They form together a new protein. And that new protein is what we call gluten. And gluten does have the properties of both extensibility and elasticity. And that is, in a sense, one of the magic things about wheat and why it's the most desired grain for bread making. And it's also one of the most problematic aspects, especially for people who have gluten sensitivities. But these are the three things that have to happen in stage two, the mixing process. We're making a piece of clay, and then we are bringing it to life through the injection of leaven in the form of yeast. And by the way, the word leaven derives from the word to enliven, to bring to life, to vivify. So the second transformation takes place is we're taking something that was dead, a piece of clay, and we're bringing it back to life by injecting it with leaven. And so these microorganisms, yeast mainly, but also bacteria, especially in our sourdough breads where we have a lot of lactic bacteria also living in that piece of clay that we've made, seek out food. And the food they seek, as we learned last week, is mainly glucose, possibly some maltose and other sugars, but glucose is their primary food source. They digest it, and then they create, as a byproduct, carbon dioxide, alcohol, and acids as a byproduct of fermentation. So this bulk fermentation is taking our big dough and raising it anywhere from, say, 90 minutes to 3 or 4 hours, depending on the dough and how much leaven we put in it. It could be overnight fermentation, but Meanwhile, there's also non-living enzymes that come in with the flour. They're part of the flour base, and sometimes they're even added by uh, millers and production bakeries, additional enzymes, mostly amylase and protease enzymes. Amylase that act on starches, protease that act on proteins, and they begin to break the carbohydrates and proteins into smaller digestible chains. So the function of the enzymes is to begin to break it all apart and make this essentially indigestible piece of clay digestible by breaking it down, but also it frees up more natural sugars, because as it breaks the carbohydrates, these sugar chains break off of the starch chains, and they become available to the yeast and the bacteria for food. And they also become available to our palates for sweetness, and they become available to the oven for caramelization later on. Now, stages 4 through 9, we're going to go through those more quickly. Fermentation is going on from this point on all the way till we take it to the oven. So we're not going to repeat fermentation, but in addition, we're doing some sort of sub stages here. We're going to, once it gets to the size we want, we're going to take it out of the container and divide it. And in dividing it, it also is going to knock out some of the gas that's been created, the carbon dioxide, through fermentation. So sometimes it's referred to as degassing. Some people call it punching, but you don't really have to punch the dough unless you want to. Some people like to punch the dough, that's okay. But we're really dividing it and into smaller units that will be the individual pieces of bread that we're going to bake. The next stage is to pre-shape it, sometimes called rounding. Sometimes rounding can also be in the form of a torpedo. It doesn't have to be a round shape. It depends on where we're headed with the final shape. But all this dividing and rounding has essentially tightened the gluten up. The gluten, being a protein and being kind of the muscle of the bread, gets tense, and it becomes very elastic but not very extensible. But by letting it rest, which is stage 6, the gluten will relax and allow us to extend the loaf to its final shape, which is what we'll do in stage 6. But then stage 7 will give it its final shape, whether it's a baguette or a sandwich loaf or a round loaf or a boule or a baguette. Any of those shapes happen at stage 7. And then they go to stage 8, which we call panning. And panning can be on a sheet pan, it could be in a loaf pan, it could be in a basket, it could be in any form that we want to use to allow the bread to go to stage 9, which is proofing. And I would call it final proofing because it's really the end of the fermentation cycle. Proofing and fermentation are very synonymous terms. Bakers use them interchangeably. The term proofing refers to the fact that we're proving that the dough is alive. And the proof of that life is growth. We're seeing the dough grow. And so we know that not only has it been growing, but it's been developing personality and character through the flavors that have been released through fermentation, the alcohol flavors, the acid flavors, the breakdown by enzymes of the starches and the proteins. All of that is releasing flavor. And so this is all happening through these stages. But then we come to the final transformational stage, baking. And this is where really it all changes radically again. Remember our definition of transformation, a radical change. And it happens through 3 distinct oven transformations. The sugars caramelize to form the crust, and that happens at about 325 degrees, which is the only place in the loaf that can get that hot is the surface, because the crust on the outside actually insulates the inside from ever getting above 200 or 205 degrees Fahrenheit. But when the crust does get above 325, the sugars begin to turn brown or caramelize. Proteins, on the other hand, coagulate or denature. They open up, they unfold, they line up, they get organized to form the skeleton interior of the loaf. And that happens at about 160. So while the outside's getting very, very hot, the inside is rising to 160 to 165, and the proteins are beginning to denature and coagulate. And then as the loaf continues to cook at about 180 degrees, the starches, and again, remember, bread is mostly starch because wheat is about 70%, 70 to 80% starch. The starches gelatinize, which mean they absorb as much water as they can until they can't handle anymore, and they explode, they burst, and they thicken everything around it. An analogy of that would be making gravy, where you put a little bit of flour in some broth, and you bring it up to a boil, and as it gets closer and closer to the boiling point, the gravy thickens. That's gelatinization of starches happening in a liquid form. And here in bread, it's happening in a solid loaf form. So we want to get, we'll say 180 is the magic number, or that's like 82 degrees centigrade, but that's not where we stop, but that's the minimum. If you do a temperature check and the dough, the center of the dough is below 180, you know that the bread is still doughy. In other words, it's still dough and not bread, but it's on its way. But if you bake it a little longer, those internal starches will also gel. And then typically with most bakeries, we're going to go to at least 190. And for our crusty bread, 200 to 205 degrees, even in the center, partly to drive off even more moisture and partly to give us a nice hard, crusty, crackly crust. Now, important note here, the yeast or the leaven, whose mission it was to raise the dough so that it can become bread, dies at approximately 180, 138 degrees Fahrenheit, and that we call that the thermal death point. Now that means that the yeast, whose mission it was to raise the dough so that it could become bread, has to sacrifice its life. It dies first. So you can't really have this transformation from a living dough to a piece of bread without this essentially sacrificial act on the part of the very organism that gave that dough life. And this is an important thing, and I think one of the factors in why bread has such an important place in many people's lives. In other words, it goes in alive and it comes out dead. It goes in as dough, but comes out as bread. I have to put it in a rhyme because that's how my students can remember it when I'm teaching this at Johnson & Wales. Another analogy, it's like a caterpillar goes in and a butterfly comes out. So that's three distinct transformations that we talked about. Let me see. Whoops, I think I went the wrong way. And that takes us to cooling, because now that we have this finished loaf of bread that has been transformed from dough to bread, we can't eat it right away because the internal temperature is still about 200 degrees. It is evaporating moisture. And remember, that's part of the definition of baking. And in evaporating moisture, we're not only concentrating the flavors, but we're also allowing these proteins to kind of stay set up and firm up. Because if you cut a bread while it's still hot, they're very fragile. The gluten strands, which you can see in the photo, are very, very fragile, and they kind of form the skeleton of the bread, but they're still weak. But as they cool, they firm up, like become the bones of the bread, so to speak. So I typically would let the loaf cool to about 120 degrees before trying to slice it. And also you'll taste more of the nuance of flavor that's been developed the closer it is to your body temperature. And then once we slice it, then we can move to the stage that we've kind of all been waiting for, which is stage 12, eating. Now in production baking, we call that packaging, but we're not going to worry about packaging here because our goal is to get to eating. And you can see again through this photo that there's something pretty compelling about properly, beautifully baked bread here. In this case, it's a little piece of toast, which is becoming a very hot commodity these days. Toast, that's I think it's comparable in many ways to pizza. So we've got through these 12 stages, we've gotten to the last stage, and we can finally eat the bread. And I want to recap for a quick second here. What we have is seeds that have been transformed into flour, flour that has been transformed into clay or dough transformed into living dough, and dough transformed into bread. And this is the journey that we've been discussing, and all of this under the auspices of baking, the application of heat to this product. So in a sense, you could say bread is the ultimate transformational food, this journey from wheat to eat, because while all cooking is transformational, as we said, and all fermentation adds another layer of transformation to cheeses and to beers and wines, I can't think of any other food that goes through these three distinct, from alive to dead, dead brought back to life, and then alive made dead again, but dough into bread. To me, this is one of the reasons why bread serves as such a perfect universal symbol in all religions and cultures, for basically symbolizes transformation itself or life. And it sets bread apart in a very distinct way from all other food products in my opinion, and I think it's one of the reasons why we're putting a lot of time and energy in these webinars into focusing on bread, as well as some of the things that we're going to also talk about later on. It's a beautiful example of, of that cell structure that's formed. You can even see the threads of gluten holding it together, and the starches have gelatinized, and they form that nice, shiny, gelled, we'd say the body of the bread. And so I want to remind you before we end today to please be sure to sign up and tune in for Michael Calanti's special class on Tuesday, May 12th. It's his presentation on tasting bread. You can bake ahead and taste along with Michael by making the Fermentology sourdough bread, unless you want to make a bread of your own. The recipe is provided by Dr. Erin McKinney, and you can go back and see her presentation along with Lauren Nichols if you want to refresh on all of that and get the recipe and details through this URL here. But we'd love to have you come back. Most of the other presentations are always on Thursday. This one will be on Tuesday. And on Tuesday, you can taste some transformed wheat. We can taste it together, and Michael will help us develop a vocabulary and a language for being able to articulate the nuances and all the subtle flavors that emerge as a result of this transformational process. If you have any questions, here's my contact info. Please feel free to write it down or contact me. You can email me at above@Johnson & Wales. My website explores more of these things. It starts with pizza and then it goes into bread and every aspect of transformation. I'd love to hear from you. And Michelle, do we have any questions coming in or time for a couple questions?
We're right at 20 minutes, so I don't want to keep you, but one of the questions that maybe has a quick answer to it that came up a few times is, are there any factors that may help create a less sour sourdough as opposed to a more sour sourdough?
Yeah, there's two ways that we know of, or that one is an obvious one, is when you're making your sourdough bread, in addition to using your starter, use some commercial yeast to speed the process up, because a lot of the sour flavor comes as a result of the longer fermentation times required in a sourdough bread. So a lot of, in France, they actually spike their breads with commercial yeast specifically to keep the sourness down, because the French don't like sour breads the same way that Americans like sourdough breads. So they purposely try to tone that down. Another, there's theories that if you keep your sourdough starter in a more liquid form as opposed to a firm form, it will be more lactic and less acetic, and so that you can you'll get less sour tones. But a lot of that, I don't buy into it totally, because a lot of that is regional. Depends on kind of the microorganisms and flora that are around at that time that can be affecting your particular starter. But I like a sour bread, so I keep my starter in a firm form. Once I have a sponge, then I add more flour and I make it into a firm starter, about the same consistency of bread dough. So for more sour, they say use the firmer starter. For less sour, use a spongier starter, and once it bubbles, put it in the refrigerator and slow down the fermentation activity. But I think that's a great question for us to explore through the rest of this series, and it may be something that Michael can elaborate on also on Tuesday as we get into some of the sensory aspects of the tasting. So I hope this has been useful to you. I look forward to hearing from all of you. Michelle, thank you for all your help, and everybody at the Fermentology site and at NC State. Look forward to hearing from you, and thanks very much.
Thanks, Peter. Thanks, everybody.